Alright, so hey everyone, this is collaborative penetration testing with Lair. That's the room you're in. So I'm Tom Steele. I'm a senior security consultant with Mission Security. I've been there for about 2 years and been doing pen testing for about 5. I'm from Seattle, Washington, and there's my Twitter if you guys want to follow me.
And I'm Kottmann. I also work with Mission Security.
This is a microphone.
Tom's colleague. I'm based out of Omaha. My Twitter handle as well.
Okay, so like I said, we've been doing penetration testing for a pretty long time. 5 years is, that's enough, I guess. So throughout my career and throughout just my years of hacking and things like that, I've noticed some problems that happen when I personally do a pen test or attacking an organization. And a lot of those have to deal with the data that you gather on a pen test. And the first thing is just data management. When you're doing a penetration test, I don't care how low install you're going to use some sort of tool. You're going to use Nmap at least once, even if you're running it just on one port, very slowly or anything like that. You use all sorts of tools to just automate the mundane tasks, and that's how you build the tools, to use them. The problem with that is every time you use a tool, you get output, and where do you put that output? Generally, it's in a text file, right? You just kind of, output standard out into a file, read it later. Where that becomes a problem is when you're doing multiple times, you're running a tool multiple times. For instance, Nmap. If you're running an Nmap 20 different times on the same host, perhaps, or the same network, perhaps, because you're wanting to do very targeted scans, you've got 20 different files. I'm sure everyone here has written their own XML parser for Nmap. I know I've written like 4. So you can parse that data somewhat. But eventually you need all that data to be pulled into one view and one centralized view so that you're not repeating your actions, you're not having thousands of files open and stuff like that. So that was our first problem we wanted to tackle, was taking all the data you've taken from all the tools and correlating it in a way that makes sense to you should look at.
And then another issue that we run into, we've got a number of different consultants on our team, and we're based, nationally all over the country. So a lot of times if we, double up on work, it's hard to share information between each other. So a lot of times there could be duplication of work. Maybe Tom is working on one thing and I don't know when it's completed. So how do you manage that data? Do you use a tool like Evernote or like an Excel, like just an Excel spreadsheet or something like that? It's hard to kind of know what the other person is working on and to not duplicate that work. So we wanted to create something that would allow us to maybe more seamlessly collaborate and share data.
The next kind of problem that I always used to run into is thoroughness. I'm pretty sure everyone runs into this. And it's, so for instance, if you're doing a perimeter assessment that's sourced from the internet, and you're scanning a bunch of hosts or something, and you have a bunch of available services on all these different hosts, how do you know that you've actually looked at every single service, for instance, right? You don't know unless you're tracking it some way. How do you track that data? When I first started out, I used to use just Vim and my Nmap files, and I would kind of like make little comment marks. It's like check this, and that's really, really slow. And then if you add more data to that, it doesn't sync well. And eventually, I started using Excel and using kind of this color formatted system that I had just myself. But then the problem is that when I'm on a team engagement or something, we can't really share that data. A USB drive with an Excel spreadsheet doesn't work so well. You can do so. You start at the top, I'll start at the bottom, we'll work over in the middle. That tends to not work so well at all. So we wanted to create a tool that would let us thoroughly check every single host, every single port manually, and make sure we did the best job that we could. So we kind of evaluated a bunch of tools that are currently out there. There's a lot that fit these individual things. Dradis is really good. It fits kind of the data aggregation and being able to share data across multiple consultants. Metasploit Pro and just Metasploit in general are good at this too, because Metasploit, you can just keep importing data into it and it'll correlate it all, and you can just view it all, and it's great. It's got a Postgres database backend that you can create and view. But what we didn't see is we didn't see any way to kind of see who's working on what and see what they can. Now there's notes in Messenger which you could use, but I think you'll see that our approach is pretty good. So we came up with this application. We knew we wanted to build something new, so that's what we did. We built this application called Lair. And I'll start off by saying that Lair is first and foremost open source. So none of this is owned by Fishnet. They own the copyright, but it's MIT licensed, so you can go forward it right now and do whatever you want with it. It's actively maintained. All of the consultants that are on the same team as me, so it's 17, 20 of us, we all use it. So if there is a bug, it's fixed very fast. And like I said, it's not going to die or go over to this pro model or you never be open source again because that doesn't fit our business model, so it would never happen. A little information about the project. This Fishnet actually gave me and Dan 2 full months to develop it. So we worked on it for 8 weeks straight, just developing this piece. And we've been working on it slowly over the past 10 months or so. And I would say that I've been working on it full time. I usually put quite a bit of time into thinking about it and developing as well. So first, what is it? It's a web application. It's built with Meteor.js. Meteor.js is a web framework built on top of Node. There's a lot of nitty-gritty that I can go into about why Meteor is cool. But if you feel like you want to create a real-time application, if you go check out Meteor, there's other things. There's things in every language you can do it. There's, for instance, there's Cran in Ruby. It's kind of similar to that. Familiar? The next thing we wanted to get into Lair in there is data aggregation normalization. So when you import data into Lair, it all gets normalized in a way that we agree with. So it doesn't just give you like, hey, here's your nmap data, here's your NSS data, here's your nextbook data, or whatever you're importing in. It actually normalizes it and formulates it into a way that centralizes the data. So anytime we import something, we actually have to meld it into our model, just like Kottmann display does it. Using a framework like Meteor gives us really cool live updates. So it uses something called WebSockets. If you're familiar with that, it's kind of things like server-sent events are kind of similar to WebSockets. But it's the ability for the server to push updates to the client. So if me and you were in a penetration test and you make a change, my browser doesn't have to refresh asynchronously using Ajax or something like that. The server just tells me that I have new data, and my browser automatically renders that data to me. So it's all live. And then for the kind of not duplicating work thing, we took the color-coded based system that I was using in Excel, and we moved it into the browser. As I said, it wasn't my idea originally. I know Burp does this. I know lots of people use colors to track things. It's just a way to do things because you can quickly see what colors, what you kind of formulate them yourself. Also, being built on top of Meteor has a very powerful client-side scripting. So what that means is you can actually drop into the Chrome browser or the JavaScript console in Chrome or Firefox. I don't know, Safari might have one. I just never use the browser, but and you can do things like update the database directly if you want to. So if you're running into a situation where you have some like obscure need to do something, like something weird, a one-time thing, or maybe it's just if it's your organization or the way you do things, you can build just a JavaScript function, paste that into your console, and then run it. So that's pretty powerful because you don't have to depend on me or Dan or anyone else implementing that directly in the application. You can just keep that script to yourself and run it. And we'll demo that in a little bit. So Dan's going to talk to you guys about kind of the architecture and how we get data into that.
Okay, so this is the basic layout. You can see on the right-hand side is basically the high-level shot of exactly how it's deployed. So there's the Meteor web server. It runs with a Mongo database for all the data management. And then we've also come up with this concept which we've called drones, which are basically just data parsers from common tools, right? And these drones, kind of broken out on the left-hand side of this diagram here. We have drones for a number of common tools, particularly the ones that we use just about every one of our tests. So Nessus, Nexpose, Nmap, Burp, and then we also have a raw JSON one, so you can kind of create one-off projects and things like that using your own tools and import it through like the raw drone. We created these in Python thinking that it would be a little bit easier for the community to contribute rather than having to do it in JavaScript, which is arguably a little trickier than Python. I think there's a bigger community in Python anyway. And we also wanted it to be kind of decoupled from the main media web application, just to make it so that, like, if you're an organization, if you want to write a one-off script to import some data into Lair, it doesn't necessarily have to be part of the formal project, right? You can just do it in your organization, import the data, and then you're good to go. It doesn't, you don't have to submit like a pull request or anything like that. It's all, so that's kind of a high-level overview of how it's broken out.
And just another note on the whole drones thing. It's really great to not have to depend on us to accept your code into the code base. You can build drones yourself and host them completely on your own repo or however you want. And then, you can just send us an email and say, hey, I'm hosting this, and we'll put it up on our wiki and say, like, hey, this tool has this drone next to it. So, for instance, I've written a few drones now for some of the tools that I've written particularly, and it's like, I don't think they really belong directly in the code base, but I'll host them elsewhere, and then if people want to use them, they just kind of work. This lets you write them. This also lets you write them in any language you want. So if you want to write them in Ruby, which is what I've been doing, you write them in Ruby. If you want to write it in Python, write it in Python. Or anything else really. So we think it works really good. We're going to move on to the demo now. And the slide might not make any sense, but one of the other things that I really wanted to focus on with the project was being able to give someone that they could just download on their laptop, start SH and run it. You don't have to configure a web server. You don't have to go configure a proxy. You don't have to install, Puma or any number of Ruby, Unicorn or something like that. You just start SH and it runs it. It starts a node web server. It starts a node HTTP to HTTPS proxy. It starts the database for you. It kind of just does everything for you. So it's very easy to just pull down and start playing with. So if you want to kind of just mess with it, like I get really frustrated when I want to mess with something, and it's really it takes a couple steps. You just want to see if you like it or not. You don't even know. So we will go into the demo, and I'm going to try to situate myself so I can see this. So if it takes me a little while to work on things, that's not the app's fault. That's my fault. You know what I'm saying? So I have app loaded up, and I've created a demo project, so I'm just going to load that up here. Okay, so initially what you see is you're brought on the centralized view. So kind of the first thing I needed to do was add Dan to my project. So Dan's also on the same number guide, and he's logged into the app. I'll just kind of show you where you do that. Here you get a list of users. You can add them into the lab as a collaborator, and they can edit and do the project. They can do everything in the project except for delete it. They can add users, etc. Okay, so the first thing you kind of skip here is this host view. This is where you're going to view kind of all the individual IP addresses and host names that you're testing. But as you can see, there's no data in there, so I'll go ahead and import some in real quick. Is that okay to see? Okay, so like I said, these are on the command line. So you just kind of name the drone that you want to run, the project ID, which is in the top corner, and the file you want to import. That's going on this one. So this first mmap command was just me scanning my local network. I have Unexploitable running on it. And it's kind of just a vanilla mmap scan. Like there's no special flags or anything like that, no version detection or anything like that. So. Okay, so it does its thing, connects to the database, parses the mmap file, and imports the 7 hosts into the app. Okay, so as you can see, we get the host here. That's pretty basic, right? So let's click on this one. And want you to kind of, let's look at port 23. So since I didn't do version detection, it doesn't know kind of what it is. So the point of this is to show how the drones work. They're kind of additive. So if you do one nmap scan without version detection, and then you do like an nmap scan with version detection, it'll automatically kind of parse it, and it knows, okay, I need to update the version, but not update anything else. So I will import. So what I did was I ran a service scan of port 23 on just that host. So it's going to connect, parse it out, and you should see it update here. So I don't know if you guys were watching that, but my browser didn't refresh, and it wasn't asynchronous. Now it takes a little bit of time when you do it on the drones because the app actually doesn't, it waits for the server to send it, so the server has to invalidate that code because you didn't make it in the application, if that makes sense. If you make a change in the app, the server knows to fire off events to change it. But if you make a change back in the database, the server has to go and kind of see that it made a change. But you shouldn't be importing data all that often, and I think it's fast enough. So that's cool. We can like dynamically update data, so we can just keep running additive nmap scans all over the network and run really small scans, and we'll get one kind of version of the truth, so to speak. So now I'm going to load up, so I see that we see that FTP server is available, and the next thing we want to do is maybe do some script scanning. Like nmap scripting is really good, so let's do some script scanning, and we'll do a full version scan, full script scan of the whole network, and see what it pulls up. So that's what this file is. So you see it updated, and this is kind of cool the way the drones work. Is the drones parse the nmap scripting engine output, and they put it in what's called a service level node. So there's nodes at the project, host, service, and vulnerability level. And so you can kind of, it's a good way to kind of view all that nmap scripting output as you're going through port by port, host by host, rather than having to look at a text file. Yes, sir? I'm sorry? Yeah, this is the output of the nmap scripting. So if you ran HTTP enum, which is a good one we like to run, you get like, found JBoss or something like that. Okay, so I said that we have nmap, you said that we have nmap, nextbos, and nessus drones, as well as perp. Let's import some nessus data. So like I said, Stan mentioned, they're all individual scripts. We like small things Unix way. So you can see that the nessus data will also update the operating system, and it's all live updated. If you have any tools that find host names, like I wrote a tool called Black Sheep Wall, it will update the list of host names as well. So here you can see that the vulnerabilities were parsed and input into what we call a vulnerabilities view. These vulnerabilities have this vulnerability view has all the things that you expect from a vulnerability: the description, the evidence, the solution. It has the posts that are vulnerable. These are linkable, as you'd expect. It has the CVEs you can add removes, and it also has an notes. So sometimes, we're actually working on getting some interesting notes put in there now. Just a little things about the app you might have noticed. You can actually go backwards and forwards and delete. You can do those on the host base and the service base level. But let's go back to the host and talk about colors for a little bit. So we have this color-based system, and as you can see, right here, I hope those colors are rendering correctly. But there's basically 5 different colors. There's gray, blue, green, orange, and red. Those colors are arbitrary to you. Like, they can mean whatever you want. To us, they mean gray means no one's looked at it. Blue means someone's currently looking at it. Green means you didn't find any serious issues. Orange means that there's something important there, but you want to go back to it. And red means like you honed it, you got shelled, there's something serious there. So it's kind of convenient when you're looking along, you're like, okay, what was my foothold in the network? You can quickly come and see it. And so the reason why this polarization system works and it's cool is because when me and Dan are test, I can just click a host, turn it blue, and he instantly sees that I'm working on this host. And Dan can do the same thing. And I instantly know that Dan's working on that host. And I know not to go work on that. And this works at all levels, the service and vulnerability level. And you can also change it just for the host right here as well. Just recently, and I mean recently as of Friday night at like 3 a.m., I added this thing to these flags because someone sent an issue in where they wanted, sent an issue in on GitHub where they wanted to basically have a vulnerability flag when there's exploits available. And so I never want to mess with the status colors for you guys. I want you guys to decide what those mean. But we added in these flags, so now you can go through and just like flag things that are important to you. And in the future, the Nessus and Expose drones, if there's an exploit in Metasploit, or exploit DB or core or whatever, it'll actually set the flag for you. So it's just another way for you to status track. While we're in here, you can, just going through the tabs, you can see the vulnerabilities for the specific host. You can see the operating systems, and you can control them by weight. And as you update that, it moves up and down. Notes, host names. So this is kind of convenient for me. I like this part. If you had a bunch of host names here, these links will parse HTTP and HTTPS ports and just create a bunch of useful links for you. So you can just, right-click, open a new tab. You don't have to like copy and paste them a bunch of times. I think that's pretty convenient. As most frameworks have, they support credentials. Credentials are always tied to a service. So if you wanted a credential like that wasn't tied to a service, it's just for a host, you can create like a port 0, which is what Metasploit and Nessus do when they're not tied to a particular service. But that's a common thing, is username, password, hash, port. Yeah, okay. I'm going to skip over this too quickly, but these go by like a weighting. So the weighting is a little bit arbitrary, but we've found that Nessus and Expose are generally better at fingerprinting both operating systems and NetApp. And maybe you run Flawless and it's better than all of those, or something like that. So when the drone parses it, it adds a weight, and so the weight representation, the highest weight will be represented by host table you saw before. So that's the operating system that you see. And by default, when you add one manually, it gets a weight of 100, which is the max. So it'll always be, you're the tester. You decide, what's the correct operating system. Just really quickly, this is a project level node. It's good for keeping, they like to keep scope and maybe just like rules of engagement or just general notes for yourself. IP address of a remote laptop or something like that. That's good to keep in here. Files. So I'll mention that the app, in kind of its beta stage, used to have its own file server that I kind of wrote, and it works really well until you're using invalid HTTPS certificates, and then the browsers will mess with you. It's kind of like its own Dropbox, and that's still on GitHub, so you can use it if you want. It's kind of fun to use during a test. But we did away with it because, like I said, the browsers just didn't like your invalid certificates, self-signed certificates, so kind of went away with it. So what we did was we just added to where you can have a general name for file and URL, because everyone uses different stuff to share files or store files. So particularly, you might use SharePoint, you might use just like an NFS server. I know some consultancies use Dropbox. I think that's a big no-no, if that's your choice. So you can kind of store files wherever you want, just put the links here. The last tab here is just a general log. So it keeps a log of all the commands that you've run and imported, and there's this kind of drone log that's showing you what you've previously identified and everything like that. Okay. Oh, yes. Let me go back to the next view. Let me talk about the service view for a second. I kind of forgot about that. This is really cool because it seems like a very common thing that we do during penetration tests is Roger, right? List of hosts that have a certain service open. So this is like kind of, these take expressions, and you kind of put whatever you want there. So if you just wanted the hosts with port 21 open, you can search and it just gives you a list. It's just a convenience thing. I will note that this is a text area with no style, so you can just Command A and Command C. So it's just easy copy and pasting. It took me like an hour to figure out how to unstyle that. So I'll have to stack up overflow, I guess. But yeah. Also, clear at the bottom, which I don't think. sorry about the view, but it also has chat.
Why?
So if you're on a project on like an internal network or something, you don't feel like launching an IRC server, like using credentials you've stolen to connect through the company's proxy. You can just chat here, which is pretty cool. It's just a simple thing. All right. So what I'm going to do now is kind of show the browser scripting stuff. All right, I'm going to try to. Is that formatting or is that not typing? Can you guys see that? I can't see it, so I'm typing more. Look good? Okay. So like I said, the database is on the server. Or the database can be here. You can do database queries on the client. Now it's all locked down pretty securely. There's an option in settings to it's kind of this bit you flip that says allow client side updates. So you actually have to go into here, and it'll give you this kind of warning of what you're doing. You're basically allowing the client to do whatever they want in the database. So this is only available to admins, but we're gonna let that go for now. So we're back here. So you can do queries like if I wanted to find one host. I can't see.
Capital O.
Good. So this is just a generic, like a find one is like a MongoDB operation. So it uses MongoDB syntax, which is no SQL database. But it's pretty much the same as a server. So find one finds you one host, and you can do queries on that and everything like that. Where this gets powerful. Okay, this is going to take some trickiness. What's the name of the file? So, I'm going to step down here. So, what this basically does is it's just a JavaScript function that we could have put on the server, but since this is like a really one-off scenario, that we don't have any place to put in the app, we just wrote a client-side script for it, and there's a whole repo of these. I think there's like 10 or 12 of them now. And so if you write these and you think they're cool, send them to us, and we'll put them up, or we can help you make one and things like that. So if you have some one-off thing that you want to do, just send it to us. I think I made one for someone on the team in like 5 minutes the other day because they wanted to generate IP address host name streams for Nessus or something. So yeah, all this does is it grabs all the hosts and then it loops through them, and for any hosts that don't have any services available, it turns them green. So if you're doing a perimeter test and you have a bunch of hosts that have no ports open, what are you going to test? You're not going to test anything, so you might as well turn them green. And so if you have 1,000 hosts and you're being really thorough and trying to make sure everything is clear and green, you might want to run this to save some work for yourself. So if you wanted to use these, you just paste them in. You just paste in the function, and this now gives you a new function. Yeah. So and from school they use that auto completion for you. Is that the right function? So if you call it, Yes. There you go. Okay. So I kind of want to reduce this down. So hopefully you guys can see it. So if you call this, boom, it runs the query on the client, and you can do all kinds of crazy stuff. So we have one that like just generates a list of URLs for us. We have one that just gives you back all the open ports in the string, so you can paste it into stuff. The sky's the limit. I mean, you have a full database here to do whatever you want.
Yeah, we've got a bunch of other scripts, like Tom said, where some of them would be like, if you want to make all like operating systems be like one consistent name, it'll update all of them, right? So everything that matches some regex, like Linux, some version, you can make just Linux, which is cool for us, because we like to group and aggregate the
Microphone
for our clients, right?
Yeah, another one that's really useful and saves a lot of time is like when you run, like when you import Nessus, and it shows you have like 500 PHP vulnerabilities. You don't really want to look at 500 PHP vulnerabilities, so we have one that's called merge vulnerabilities by regex, and you can just be like, PHP, merge into the same, and then you can kind of look at them. You can verify each CVID, but you don't have this whole list of just gigantic results. And that's kind of the idea behind this whole project, is getting all the automated data out of your way so you can focus on manual testing. So that's the demo. The next steps that we have. Kind of looking back, I realized that we should have broken the drones off into a little bit smaller pieces. They should be able to operate their own, similar to how Metasploit has their data models. They're basically using the active record ORM in Rails, and that's how they kind of manage. That's how you can like query the database. We're going to do that same thing. So we're going to build an ORM with Ruby and Python. So we have some MongoDB ORMs. So basically, it lets you do things like just do host.new and then with methods, and you can indicate all the needed things. You don't have to use basically we're doing now a dictionary, which is how we're updating them. So we're going to be working on that. And that, in particular, will allow us to do the Metasploit integration really easily. So we're going to build a drone that basically syncs up Metasploit. I'm trying to think of a good way of how to make that like reactive without messing with the database. So if you're like a Metasploit guy and you know a lot about it, and like maybe if there's any way to like hook into the database events, let me know, because we'll work on it. And then we want to complete the wiki. Basically, the app is downloadable via like a 7-zip archive for Linux 64 and 32-bit and then LSX. But that's not for everyone. You might want to, for instance, run it on your own port. Use Nginx as a proxy. Maybe use another among the DB instance that you have already running. So we want to put some steps up on how to install it yourself and kind of get like a very production ready install. Also, we'd like to give details on how to start developing the app. So there's no instructions on, for instance, how to download the GitHub repository and start immediately messing with the application. You'd have to go learn Meteor and learn about Meteorite and Nodes to get those tools. So I kind of want to give you guys some steps on how to do it, and also documentation on, once this ORM is defined, all the methods that are available so you can start using it. So yeah, thanks to Fishnet for sending us, giving us the time. Thanks to DerbyCon for letting us come and speak. It's really been a lot of fun. And thanks for you guys for coming to talk. Here's a link to the code, and then our Twitter. And if you have any questions regarding Lair, and you for some reason don't want to follow me, I'll usually follow you back. You can use the hashtag and kind of ask me a question. So that's it. So we have like 5 or 10 minutes for Q&A. Does anyone have any questions or want to see anything else in the back?
Do you have any good reviews in there to facilitate getting the information out in the report that lend themselves to consolidating or rolling up the results?
Yeah, so yes, we do, in fact. So I'm going a big fan of like the Unix philosophy and having a lot of really small parts. So I didn't want a reporting framework in here because I feel like people generate those reports and give them to customers and they're just like really bad. I can't close that out. It's too but basically it has this export functionality. You can export this to something like Netcat or HTTP listener, and it packages it all up into a JSON package that you can go and then parse yourself and generate your own reports based off the data. So it'll package it all up and let you export it. Yes, sir.
Could you just go back to the contact info slide?
This one?
Yep, that's the one.
Yep. Any other questions? Sir, yes?
Can you, is the project ID randomly generated, or do you have any control over that?
The question was the project ID randomly generated. So yeah, it's randomly generated by MongoDB, which I think is just like a timestamp to generate it, so it's all random.
All right.
Yeah. It's so you can keep things individual, but you can have a project name. So if you wanted to have your journals work by project name, you could. We just thought that was kind of you might do something crazy like modify a project you didn't mean to. Any other questions? Yes.
Host or services view, can you sort by color?
Yes. Thanks for reminding me.
What was the question?
I will repeat it. It's in the host and services view, can you sort by color? And in fact, yes, you can. So these are all filters. So if, for instance, you click green, it removes the green ones. I think I'm clicking green. I don't know if I'm clicking green. And so you can filter all of this based on color. And that works on the host, services, and vulnerability too. Thanks for reminding me. Yes?
How are conflicts between different inputs handled? Is it just through the weighting system? You had to manually do that?
For the operating systems, in particular, it's the weighting system. For other things, it's basically keying off the unknown keyword. It's like for version. If it runs and the version says unknown, it'll import it. Or am I wrong? Does it import the latest version? Because Dan wrote the drones, so I'll let Dan talk.
Okay, so as Tom mentioned before, everything that the drones do are additive, right? We're not going to remove anything. So like if you do a scan of a host and you do a full port scan, you import that data, and then the next time around you do a scan of limited number of ports, right? We're not going to remove any ports that weren't found in the second scan, right? They're still going to exist. And so the same concept is with all the data, right? So when it comes to versioning, we'll take the latest version that comes in and add it. Is that okay? So long as it's not unknown. Unless it's unknown, then we may keep the version that's already in there. But that's only for like the software versions. For the operating systems, we always add a new one, always. So and it's just added with that weight, and then what you see displayed there is whichever one has the highest weight.
And you can, it's pretty easy code, so you can always modify how that's done. In particular, someone who gave us the idea to have the exploits put in as a vulnerability node. He wanted them turned red when there's an exploit available. I don't agree with that, but that's fine because you can just go modify it really quick and you can do that. Yes?
What's the installation process look like, or the setup process? You've got maybe 2 pen testers, they each have a laptop, and then you have a server that's sitting out in the data center that you're using for external pen tests. What's the actual setup process look like with that?
Yeah, so that's how, so the process was, what's kind of the detailed installation process if you didn't want to run it on one person's laptop and you want to kind of have a server somewhere in a data center or something like that. So you could certainly run it with these packages and it would work just fine. Our setup at Fishnet is we have, it's basically just a node server, so it's just running node main.js. It has a root URL and a Mongo URL, which are environment variables, which tell it where to listen and how to do that. So we have those running. The application forces SSL, so it doesn't have a proxy. So we use Nginx as an HTTPS HTTP proxy, so we have to run that. And then we run our own Mongo database instance. So you set up MongoDB, Nginx, the node server, and you're good to go. As far as getting data in, you have to install the Python package somewhere. And it's just a pip compatible package, so you just do pip install. You set a Mongo URL environment variable, which tells the drones which database to talk to. And then, as long as you're all running the drones, it can important. And we keep an API version on the server that the drones check, or should check. If you run it yourself and you don't check it, it's your problem. So, I don't know. But so if for some reason you're running an out-of-date drone and the API has, like, there's some kind of breaking change, the drone won't anymore. So, yeah. And that's the kind of thing we really need directions on. So if you're looking to contribute and like you're really good, like you're like a really good like DevOps type person, and you can come up with like some really cool like Nginx, kind of like a really clean looking good Nginx configuration, and like have really good instructions for like maybe setting up upstart services and all that. That's like a web awesome web idea and a good way to contribute. Yes.
So for some of the more Word files, how would something like that look on Mac?
So the question was like for manual testing and burp, how would we import it? Basically, the way the drone works is it works just how you probably could expect it to work. If the burp scanner finds an automated finding, it imports it. Is there any way to even like create your own finding in burp? Like if you found a SQL injection manually, do you go into burp and like say found SQL injection? I don't think there is. I don't think you do that. You probably just put it in the app and be like, hey, found SQL injection. And you can create manual vulnerabilities manually and all that stuff. So there's really nothing keeping you from doing that manual testing.
So like my fuzzing results, right? So I can, if I go and I fuzz this like a web service or something, and I want that in there because I need to keep track of that as far as.
If it's in your burp state, you could definitely import it. You probably have to do some custom parsing and import it. It brings up a good point that you bring up, is that currently the app doesn't have sort of RESTful API. There are meteor libraries where we could do that, and we've thought about doing that. And what that will give you the power to do is to create like a burp plugin without having like a burp plugin that speaks to MongoDB, which would be I think would be kind of crazy. But if the burp plugin could speak to a REST API, then it could just run and import anything you want. So yeah. Another cool thing about MongoDB in general is it's schemaless. So like if you want to just start adding your own stuff in anywhere, you could do it. So how you render that in the app is completely up to you, but you can store it in the database and then query it from the browser if you wanted it manually or whatever. So yeah, the sky's the limit. So yeah. Yes.
Do you ever consider writing a shared file import drone so that customer tools can export to a shared text file and you can import into the populated host services just so we can get a tool?
Oh, okay. So the question was, have we considered writing like a generic, like formatted output type drone that we could give to like a customer if they wanted like a CSV all the host supports?
No, like if, for example, I write a variety of custom tools. I want to output in a format that I can easily import into Lair. You had a standard format that was exposed to IP.
So even just like a CSV importer, a CSV drone, you output to the right CSV format.
Yeah. Okay. So yeah, there's actually a raw JSON drone. So if you make your stuff compatible with that, it will import it all for you. The only thing I'll say there is that might change. So like I said, when we go with the ORM model, we might be discovering that we're able to kind of do a whole lot more. And I think even doing something like that, you'll find it would be easier just to write it yourself because it'll be so simple. If you have any Ruby or Python knowledge or anything like that. And if you guys need an ORM for any other language, like I'm a language geek, like I switch languages just like every other week. So if you want like a Scala ORM, it's like a good reason for me to learn Scala or Go. Just write it and go. Okay. Any other questions? All good? Yeah. All right, guys. Thanks a lot for coming out.
Football one. Fuck.